and welcome to Disastrous History. Today we're going to talk about the Ronan Point collapse on May 16th, 1963 in London, England. Now, Ronan Point was a 22-story tower block full of flats that exploded and partially collapsed on May 16th, 1963. Now, this was actually 23 stories, but because the UK counts the ground floor and then starts the first floor at what is actually the second floor in the United States, we're going to do it the UK way. So just if you were thinking in the United States this was actually 22 floors, it's actually 23 floors, but the ground floor doesn't count as the first floor. The first floor is actually the second floor anyway. Moving on. So we're going to go through the story real quick, and then we're going to do an analysis of what actually happened and why this particular disaster occurred. So, on the morning of May 16th, 1963, a lady by the name of Ivy Hodge, who was living in flat number 90 on the 18th floor of Ronan Point, woke up and decided to do what probably every British person does every morning, make a cup of tea. However, she needed to make that cup of tea on her gas-powered stove. Now, at the time, the UK was mostly using coal gas, which is essentially, they call it town gas, it's coal gas. Essentially, it's a gas that's manufactured by the burning of coal in the absence of oxygen. Essentially, they superheat coal and then collect the gas to use it as a cooking gas or whatever. It is generally made up of about 50% hydrogen, 30 to 40% methane, some ethylene, and then some carbon monoxide. It is very smelly, it is very toxic, and it is very, very bad. And it is lighter than air, so when it leaks, it pools, it goes up higher, it floats away. So she gets up morning of May 16th, 1963, about 5:45 in the morning to make herself a cup of tea. She gets up, doesn't know anything and notice anything usual, walks through her bedroom, into the hallway, into the kitchen. She goes over to the stove. She pours water into the kettle, puts the kettle on the stove. Now, she'd been having problems with the pilot light on her stove and had shut it off. So every time she wanted to light her stove, she had to turn the knob on and then light a match to light the actual stove to get it to burn. So that's what she did. She turned the knob, she lit a match, and then all of a sudden, everything around her exploded in a massive fireball. The next thing she knew was she was waking up on the floor and most of her apartment was gone. Now, this seems pretty straightforward. There was a gas leak at some point around her stove and a gas explosion occurred. Now, the apartment that we are talking about in particular is this one right here. This is Ivy Hodge's apartment. She was inside the kitchen. That is the doorway into the kitchen. So there's a balcony doorway right here. This wall right here that is currently missing, this entire floor area, this was the living room kicking out here. This over here, this floor where you can see the floor is hanging down, this was the bedroom. There was a wall here. You go into the kitchen. On the other side of this wall was the kitchen, and then there was a bathroom on the back side. I'll show you the diagram of the apartment here in a minute. Now, it blew up her apartment here. It traveled through the kitchen out into the living room and then blew out the walls on the exterior of the building. And when it did that, it caused the entire portion of the building to collapse from the 22nd floor all the way down to the first floor. Just this specific section right here. Now, why exactly did it cause this entire one corner of the building to collapse? So the first thing we have to do is talk about the explosion itself. So let's go ahead and look at our diagram of the apartment itself. So here we go. We have our apartment here. This is the diagram of flat 90. As you can see, layout of apartment 90 right there. So let me use purple for Miss Hodge. She gets out of her bedroom, she walks through the door here, she walks in here, she walks into the kitchen, she fills up the kettle right here, she walks over to the gas stove. She is standing at the gas stove when she lights the match. Draw her right here, okay? She's standing right there. As soon as the explosion occurs, unbeknownst to her, the entire upper portion of her apartment had been full of gas. Now, when the explosion occurred, it would have propagated through the kitchen, out this doorway here, into the hallway, into the bedroom, through the living room, and then it would have overpressured against these walls. Now, the thing you have to understand with gas explosions is they're not explosions in the typical sense until they have containment. So what I mean by that is if you take a cloud of methane and it's just in open air and you have it at its 5%, which is the lower flammability limit, you stick it in there, it'll just make a fireball, it'll go out. It won't explode, it'll go whoosh because there's a lot of air being pushed out because of a sudden increase in heat, and then the air will flow back in, but it won't really create that explosion that you would expect. However, when you have it contained inside of a box or inside of a building, such as this, as it expands outward, it hits resistance, right? Because you're building a room is a container, and when it hits those walls, that energy has nowhere to disperse, so it rebounds back, and then it rebounds back, and then it rebounds back. It just keeps bouncing back and forth until eventually it builds up so much that it causes it to break the connections of where walls are. If it's a lower explosive limit, it will push them out. If it's stoichiometric, it will cause it to shatter in a massive explosion. And this bouncing back and forth takes a millisecond. It's not like a multi-second thing. It's a millisecond. It travels incredibly quickly. So when this happened, it blew out this wall here, this whole wall right here, all the way down to the bedroom, and it blew out this wall here, which if we go back to our previous picture, you can see how the bedroom wall is gone, this wall out here is gone, and all that is remaining is the kitchen wall, and then there's a bathroom wall right there. So she is in here, she gets knocked unconscious, and then wakes up with fire over her head, and then it's out, and the rest of her apartment, her flat, is gone. What collapsed here is from basically right here through the bedroom all the way, this whole section right here fully collapsed downward. Now, the interesting part about this is that at no point did Ivy Hodge ever smell gas in her apartment. And now this isn't like natural gas where they add mercaptan or propane where they add mercaptan. Coal gas stinks on its own. So it's likely that she would have smelled it. Now, the thing that's interesting about this is it's possible that because it had been leaking for so long, it started to leak early on. She may have smelled gas early on, but because it was leaking so slowly, it may not have actually... It may have been leaking enough that she never actually, she got used to the smell. Because that's a thing that happens with people. They have odor fade, where essentially your brain starts to filter out that smell because you get used to it. That's why when you go into your own house, you can't smell your own house. But if you go into somebody else's house, you can smell their house. And if somebody comes into your house, they can smell your house, but they can't smell their own house. That's what happened. It's probably at least partially what happened here is she was suffering from odor fade from regularly being able to smell the gas as it was leaking. Now, another one of the interesting things about this particular gas explosion is that she regularly used her stove. So she was regularly lighting things on her stove, which in theory should have caused an explosion early on. The apartment complex itself, the tower, would only open about 2 months, and she'd been living there about a little less than 2 months at that point. So one of the things that I want to do here real quick is try and figure out just how long it would take for that coal gas to leak at assuming it was a clean break, because the actual cause of the gas leak was determined to be a faulty nut on the flexible connection from the gas line in the building to her stove itself. The individual who installed it overcranked it, and it cracked the actual nut itself, which was allowing the leak. The official report states that somehow the nut cracked and then the gas line disconnected fully, and it was fully blowing into her flat the entire time. But I want to real quick do the math and see just how long it would take for all of that to eventually reach a flammable mixture. Now, the lower flammable limit for coal gas is 5%. So in order to do our calculation here, we have time for the lower flammable limit. You have to forgive my writing. And then you have your volume of the room, which I'm going to have to look up real quick because I don't know off the top of my head. You have your percent LFL for this, LFL, divided by 100. And then the whole thing is divided by your flow rate, which is should be in, meters squared, or cubed, per second. Wow, that was terrible. Per second, okay? That says flow rate. Flow rate. So this is your formula to determine how much time it will take to reach the lower flammable limit for a gas inside of a compartment. So we're going to make a couple assumptions here doing our math real quick. So we're going to assume that her bathroom door was closed. We're going to take out the balcony, and that's going to leave us our bedroom, living room, and kitchen because that's the primary locations where the explosion occurred. And the total square footage of that area is 540 square feet. Feet squared. Now, they are 8-foot high ceilings, so we multiply that times 8, and we get 4,320 cubic feet. Feet cubed. Okay? Now, we have to put that into cubic meters because everything in our calculation is going to be meters, and that is 122.33 meters cubed. So we'll put all of that into our handy dandy formula here. All right, so we have our time to LFL here equals 122.33 meters cubed times 5/100. All of it divided by the flow rate of the fuel. Now, the assumption here is that something happened at 5:45, or something happened overnight that broke the nut completely off and was allowing full flow of gas into the apartment. That seems unlikely, but that's the assumption we're going to make because that's the assumption they made in the investigation, was essentially that it was going to be flowing fully into the apartment. Seems unlikely. Seems likely this was an incredibly slow leak over several days to several weeks that eventually built up. Remember that coal gas is lighter than air. It's primarily made up of methane, hydrogen, and carbon monoxide, all gases that are lighter than air, so it would sit at the ceiling. So if it's a very slow rate and it leaks and slowly descends down in a thing called layering, even if she was igniting her stove on a regular basis, there's still a good possibility that it never actually reached the lower flammable limit at the ceiling to actually cause an ignition, or not enough heat got up there to actually ignite it. So there's always that possibility. There's also the possibility that it was leaking so slowly behind the stove that even if she did ignite it, it wasn't putting out enough gas at the time to cause an ignition to go back to the actual source of the leak. It's very, very possible, if not likely, that during the explosion, the actual gas pipe broke. The nut broke apart during the explosion when the stove was pushed away from the wall, because that's what happened. It fell over, and that's possibly when it broke. However, we're going to make the assumption that it broke off and it was fully flowing into the room. So the flow rate at the time was 120 feet per hour. Feet per hour. We need it in flow rate of fuel in meters cubed per second. Feet cubed per hour, not feet per hour. Feet cubed per hour. So we need it in meters cubed per second. And I can't do that math in my head, so I pre-did it, and it is 0.00094 cubic meters per second. So now we do all of our math here real quick. So we do 5 divided by 100 is 0.05. and then we multiply that times 122.33, and we get 6 point, erase that, we get 6.12. We're going to go with 3 sig figs here. And then we divide all of that by 0.000994. So we divide that by 0.00094. We get 6,000. Erase this out of the way. 6,506.9 seconds. Now, we now want to divide this by 60 to get minutes. So we divide that by 60. We would get about 108 minutes, which is about an hour and 48 minutes, almost an hour and 50 minutes. So, explosion occurs at 5:45 in the morning, putting an hour and 50-ish, an hour and 45 minutes prior to that, we end up at 4 o'clock in the morning. Is it likely that something happened at 4 a.m. that caused her stove to completely break apart and allow full flow of gas into her apartment? Probably not, no. She lived alone. She was asleep. There would have to be something major that occurred that caused her stove to fully break apart. It's highly unlikely that there was so much gas flow that it suddenly broke apart. It's highly unlikely her stove magically fell apart and she didn't notice it when she went to light it. In addition to that, if it was releasing at that rate for that period of time, even if she had gone through odor fade, it's likely she would have smelled it because there would be a very, very significant amount of gas coming out at once. It would have been full on blowing out of the back of her stove, and it would have stank very bad. So it seems much more likely, based on this and the circumstances surrounding this, is that this was a slow leak over a period of days to weeks even before it actually reached the lower flammability limit. Now, what's fascinating about this is Miss Hodge used her stove earlier that evening, the night previously. She used it early in the evening to boil kettle and make a stew, and then just before she went to bed at 10:45, she heated some milk on the stove to make a cup of Ovaltine. Young Frankenstein reference. Anyway, sorry, besides the point. So she was using it, and it wasn't causing a problem. So either something happened between 10:45 and 5:45 that caused her stove to break apart, or at some point through the night, it finally crossed that 5% threshold to actually cause an explosion. Now, based on damage, it was a very low explosive limit explosion. There's not much fire damage. There's very little actual fracturing of the material. Most of this damage is due to the actual collapse of the building. If we go back and look at the actual damage itself, you can see here there is no scorching on the walls. There's no fire damage in here. None of these have any fire damage. If we look at another photo of the ground level, where's my ground level photo? You can kind of, this one right here, you can kind of tell that there is no fire damage anywhere. If you had a stoichiometric explosion or something of that nature, you would have some kind of scorching on the walls themselves. But the only thing here is actual collapse damage. So if we make the assumption that the gas leak had been occurring since the installation of the actual gas line, which makes the most sense, then why did we end up with a full collapse of every living room in this corner of the structure? Because the bedrooms up here collapsed, and then from here, so the bedrooms from the 22nd floor to the 17th floor collapsed, and then from the 16th floor down, it was just the living rooms. So why exactly did that happen? Because if we make the assumption that this was low explosive limit, that it was a very weak, relatively explosion, there was very little fire damage, why did this collapse happen? So let's get into that because it is interesting. The reason for that is because of the way the building was built. So, what happens with this building when it was built is they had all of the floors, the walls, the ceilings, and the stairs poured as precast concrete pieces. They would be made in a manufacturing facility, shipped to the place, and then they would make them floor by floor. So essentially what is happening is if you look right here, you have your floor right here, then you put your concrete wall on top of it, and then you put another floor, and then your next wall up supports the wall, is supported by the wall below it. So it's essentially like a giant stack of cards. All the way up, each floor below is supporting the floor above it, and then the floor above it, and then the floor above it. In order to do that, they had to make sure that it was tied together well. And how they did that was like this. So you have your wall here, right? This is your precast wall. What they did was it went like this, and then they would cut out a chunk of the wall like so. So you have your chunk of your wall right here, and then they would take their floor and they would lay it on top like that. So now you've got your floor sitting on top of your concrete. Then, when the wall was constructed, they put in a rod. It was called a lifting rod that would help them be able to pick it up with a crane to make it, because obviously you can't just move a giant concrete wall. You need to have something to be able to hook to. It's not like you can just pick it up and carry it. So they would put a rod in top of it that you could hook to and carry it around, and it would stick up like that. And then they would put a bolt. They would thread the top of the lifting rod, and they would put a bolt on top like this, right? And then you have your next wall up. And what they would do is, in order to make it so that this lifting rod would connect to the wall above it, they would install a little hat, essentially, where they could stick it down, the lifting rod would go inside, and they would tighten the nut down so that it sat directly on top of it. In addition to that, I made my floor a little too shallow here. In addition to that, you have your floor like this. They would take a piece of metal and they would slide it over the top of the lifting rod, and then they would it would come over here, they would get another bolt, and they would bolt it down into the concrete of the floor like so. So that it was tied here, it was tied here, and it was tied together this direction. So you've got a tie between this wall and the floor, and then you have a tie between the wall and the wall. They would do the same thing on the next level, so that it was all sticking together. And then this gap right here was supposed to be filled with essentially cement. There would be a gap right here that would also be filled with essentially cement, so it would basically be all stuck together, and it would be all well packed. It would be firm and solid and all of that. That is what was supposed to have been done. That was not what was done. So, what they did instead was, instead of put this bar here, they just kind of put it in there, and then they didn't bolt it down. They would put this over the lifting rod, and then they wouldn't tighten this bolt. And then instead of putting the cement in here to really solidify it and make sure it didn't go anywhere, they just filled it with trash. Whatever trash they could find, just filled the whole area. So, when you have your explosion occur, we have our gas is filling up our apartment complex, right? It's filling up our apartment. It's been leaking for an undetermined amount of time at this point. It's filling up all right here. All this is filled with gas. But instead of having this tied together, that's gone. You have this has gone down all the way to here. Okay? This nut, not tightened. It's just sitting there. This, not tightened. It's just sitting there. This is just full of trash. It's literally being held up by the weight of the concrete at this point. That is essentially the only thing keeping it up. So you have your cloud of gas down here. When your ignition occurs, comes through like this, through the cloud, your first failure point is going to be right here. It's going to push the top of this wall directly out. It's also going to lift this floor directly up because it's not going to be a uniform directly across. It's going to be up and out. So you've got lift up here, you've got push out here. So this wall is going to lose the weight of the floor as it lifts up, and it's going to fall like this. Now, once this wall is gone, floor no longer has support, wall no longer has support. Wall is going to fall down, followed by the wall directly above it, the wall directly above it, the wall directly above it. It's going to plummet straight down. This no longer has the support here. It's going to collapse down. Now, what happened here was it wasn't just because this happened on the 18th floor, right? So it blows it out, blows out the wall on the other side. So you lose both the living room wall where that corner is, and then the bedroom wall. So let's pull up our diagram here real quick. Our wall connected right here, like we just talked about. This wall is gone. This wall is gone. So everything above this wall, these two walls, going to come crashing down. This floor right here, no longer supported, is going to come crashing down. This floor right here is going to be partially supported by these walls here because they're still intact. It's going to break, but this wall is also going to come down because it no longer has support. It's going to get lifted up. It's going to crack just like that. If we go look at our collapse of the structure again real quick, you can see that's exactly what happened. Right here, this is the 18th floor. You can see how the floor is broken. It's completely gone here. Now, on the 22nd floor, there was a husband and wife who were living there. They had refused this apartment numerous times in the 2 months since the building had opened. They eventually moved in because the home that they were originally living in was condemned. So they eventually moved in there, and they would die in the collapse. The other two people that died in the collapse lived on the 17th floor, which would be directly below Ivy Hodges' apartment. So 22, 21, 20, 19, 18. This is Ivy Hodges' apartment. They lived in this apartment right here. They were both asleep in the bedroom. Ivy Hodges' bedroom floor collapsed down on top of them and killed them. Now, the initial first collapse would have been this exterior wall right here. And then, once this exterior wall collapsed, it all landed on the 18th floor, and then it subsequently collapsed straight down from there because all of that concrete was sitting on the 18th floor, was sitting on the walls for the 17th floor, which were not designed to hold that much weight. So when they landed, it all came crashing down. Now, the reason that only 4 people died in this collapse is because it was 5:45 in the morning, and the vast majority of people were asleep in their bedrooms. All of the bedrooms for this apartment building were right in this line right here, right where these windows are. So, couple lived up here, couple lived right here. Ivy Hodges' apartment, she's in her kitchen. She is unconscious. Unoccupied, 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 unoccupied. This is one of those disasters where had it happened an hour later, an hour and a half later, the death toll from this disaster would have been catastrophic, would have been likely in the hundreds. But because of the time it happened and because of the way it happened, it saved hundreds of people's lives. Now, in the aftermath of this disaster, there were a bunch of changes made to, well, all building codes. Essentially, they were redesigned so that they had to be required to be able to withstand an exterior explosion, an interior explosion, a fire, a car crash, all of that crashing into the building without a catastrophic collapse. Had this building had a fire, it was very possible that this building would have collapsed during a fire. They did several fire tests prior to opening the building, and they failed all of them. it's very likely that it would have collapsed, especially considering as eventually they would rebuild the structure, and when they were doing the rebuild of the structure, they found several parts where they hadn't done anything, where at least on the 18th floor they had put the bolts in the holes. In the lower levels, they didn't even do that. They didn't even put the bolts in the holes. They didn't tie it together at all. It was essentially a giant concrete house of cards. It was basically all it was. When they tore it down, so they rebuilt it, no one wanted to move into it for obvious reasons, and then they ended up tearing it down. When they tore it down, the person that basically told them, hey, if you don't do this, it's going to collapse in 15 years, was shocked the building was still standing. That's how poorly built this structure was. It is an absolute miracle that this building stayed standing for as long as it did, because they built it as quickly as they possibly could, and they cut corners by filling in areas that should have had cement with trash, and not connecting bolts, and really not following much instruction at all. It's one of the big what if disasters in history. It was a disaster, 100%. 4 people died. But if it had happened an hour and a half, 2 hours later, it would have been way, way worse. Now, if you're wondering what happened to Ivy Hodge, she survived. She was knocked unconscious during the explosion. She suffered from some minor burns, which is obvious. She was in the middle of a gas explosion. She was also in shock. And in the aftermath of the explosion, she moved out and she took her stove with her and installed it in her new home and continued to use it because it was a perfectly good stove. The only issue was the cracked nut. In the aftermath, the UK went through and looked for all of the types of nuts that caused this particular crack, because it wasn't like he super over tightened it. He didn't crank it down. It was a hexagonal nut. It was just poorly designed and it cracked. So they went through and found all of the hexagonal nuts and replaced them with octagonal nuts to make it so that this couldn't happen again. They couldn't have this crack happen again. But yeah, it's a really interesting disaster from beginning to end. Essentially, you have a disaster that causes another disaster, but not in a way that you would expect. There's a bit of a disconnect there between the gas explosion, which shouldn't have caused this much. It should not have caused this collapse, especially a lower explosive limit explosion. Generally, with lower explosive limit explosions like that in a wood frame structure, it'll push the walls out, especially with like methane. It'll push the walls out at the top, and then like the roof will fall down, but it won't break it apart. It'll cause it to collapse, but that's just because it's held up by nails. I've seen several lower explosive limit explosions where it just kind of pushes the walls out and it doesn't collapse at all. In a concrete structure with this much engineering that should have gone into it and this much tie to keep it in place, there's no way that an explosion of that nature should have caused this much destruction. But because of cost cutting and corner cutting and wanting to make money, this is what you end up with. And they got incredibly lucky this time. So with that, we reached the end. I hope you guys enjoyed it. As always, let me know what you think in the comments. I look forward to doing more. As always, stay safe, and remember to check your smoke detector batteries.